right, so we are working on day 6 homework. So if you could answer the questions 1 through 5, make sure that you've read the directions. So answer questions 1 through 5 and we'll explain it. Okay, so here's question number 1. At what values of x does the graph have a non-removable infinite discontinuity? Describe the behavior of f of x as x approaches this value from the left and the right. So the proper way to write this is going to be x equals -3 is a non-removable infinite discontinuity. That's going to represent our vertical asymptote. And this is the proper way to write that statement. As x approaches -3 from the left, f of x approaches positive infinity. And as x approaches -3 from the right, then f of x approaches negative infinity. All right, number 2. At what values of x does the graph of f of x have a removable point discontinuity, and describe the behavior of the function as x approaches this value from the left and the right. All right, so we are going to be focusing on that whole. So x equals 3 is a removable point discontinuity. As x approaches 3 from the left, f of x is equal to 5/3. Okay, well, how did I know that that was 5/3? Because the point was given in the directions. All right, make sure you know both notations. With the minus sign, it means from the left side. So we're on the left side of -3, and then the plus means on the right. So we are on the right side of the number 3. Okay, number 3, what factors are guaranteed to be in the denominator of the equation, and then give a reason. Well, since f of x is discontinuous at x equals -3 and x equals 3, then x plus 3 and x minus 3 are factors guaranteed to be in the denominator. Number 4, what factor is guaranteed to be in the numerator but not in the denominator? And so it says since x equals -1/3 is the 0 of f of x. And how did I know that? Because it tells me that it has an x-intercept at -1/3, 0. Then 3x plus 1 is a factor in the numerator, but not in the denominator. So just real quick side note, when you're trying to take a fraction and put it in factored form, the denominator is the coefficient of the x, and the sign is going to, if this is a negative, this is going to be a plus, and then the numerator is going to be what the constant is in that factor. All right, number 5, domain and range. And here is the domain and the range. All right, now we're going to look at it from a table. Let's take a look at number 6. Actually, you guys answer questions 6, 7, 8, 9, and 10, and then I will go through them. All right, number 6, based on the table, what factor is guaranteed to be in the numerator of the function but not in the denominator? So since x is equal to -4 when the function is 0, then x equals -4 is a 0 of the function, right? Remember, if it's in the numerator and not in the denominator, we're looking for the intercept, which is where the function equals 0 for the y value. Thus, x plus 4 is a factor in the numerator, but not in the denominator. Okay, number 7, at what x value does the graph have a vertical asymptote? So we have to look at two different things when we're looking for the asymptotes. We need to consider this spot and this spot, being that it's undefined. And then we need to look at both sides of the numbers to the left and to the right, and then determine what we have. So here we go. H of x has a vertical asymptote at x equals 3 because as x approaches 3 from the left, h of x approaches negative infinity, right? That's a really large negative number. And x approaches 3 from the right is a really large but positive number. So we can see that those are going to be an asymptote. Number 8, what x value does the graph have point discontinuity? So again, we're looking at where the function's undefined, but this one right here was already a vertical asymptote. So what we're going to do is focus on this one right here. And it says h of x has point discontinuity at x equals -3 because as x approaches -3 from the left, it is, and as x approaches -3 from the right, notice that it's approaching -0.33333, and that is the value of -1/3. Okay. 9, does the table indicate horizontally asymptote? I can't even say that word. And basically, is there a horizontal asymptote? If so, indicate the equation of the horizontal asymptote and give a reason for your answer. So if we look at that, we're going to be looking at the end behaviors. So let's take a look and see the end behaviors of the graph, what's happening. Since h of x is approaching 2 as x approaches -infinity and positive infinity, then y equals 2 is a horizontal asymptote of h of x. Number 10, completely factor the equation of the function h of x. What connections do you see between the factors of the equation and the conclusions that you made in questions 7 and 8? So take a look at what we did 7 and 8. That was talking about the vertical asymptote and the point discontinuity. So let's just take a look at what we're going to start here. So we know we can start off by factored form here because we're factoring out the original h of x. H of x was given to us. So we're going to factor out the 2 and then take this x plus 3x minus 3. And then what we're going to do there is further factor. So this is completely factored form. And now it says, what connections do you see? Let's take a look. So x minus 3 is a factor in the denominator only. So x equals 3 should be a vertical asymptote. Then we have x plus 3 is a factor in the numerator and the denominator. So that should be point discontinuity. And again, we were only making the connections from 7 and 8, which was a vertical asymptote and then point discontinuity.